So 9.6 is going to be different than what you've learned. When I say different, the first 5 section deals with graphing, and the last 2 sections are what are going to deal with these expressions that deal with simplifying and even goes into something called trig proofs. So what I'm going to show you here are some of the main things that you're going to use. On the printouts that you have at home that I've given you, you may not be able to read these first 2 boxes, but it's a picture, and so I can't really edit that, I don't think. So I have to retype it if I'm going to fix that, but I'm not going to. So write it down. What you need to know from Unit 8 and from Unit 9 is that the cousins are not equal. Well, let me say it like this. Sine is not the same thing as cosecant. Cosecant is not the same thing as sine. They have to be reciprocals in order to be equal to each other. The cosecant is equal to the reciprocal of sine, and the sine is equal to the reciprocal of cosecant. In other words, the opposite over hypotenuse here is equal to 1 divided by the hypotenuse over opposite there. That's how it works. You have to know which functions are cousins to each other. You have to know which functions are reciprocal identities to each other. You should also know which quotients are the same thing as each other as well. Meaning I can switch tangent of an angle into sine of the same angle divided by cosine of that angle. We learned that last unit. Or we can also switch cotangent of an angle to cosine of theta divided by sine of theta. So let's do a quick review. Anybody who's watching this video at home, it doesn't matter. They can always fast forward. For the people in my 3rd period class, with North person, I want you to review the 6 reciprocal identities with the South person. Hopefully you can tell them what you got. And then South person, what are the 2 quotient identities, and have that discussion with your partner. Discuss, please.
Okay, so since I cosine what is it called? Secant? Secant is equal to cosine. So of course it's going to but otherwise it doesn't make sense. Because sine is equal to sine, and same thing with cosine and secant. And then there's the tangent. Cotangent is we flip too. But then we have the tangent equals sine divided by cosine. So of course, cotangent is reciprocal, but so it's just cosine.
So one thing I want to remind you, since now that you've reviewed things you're already supposed to know, you don't have a cosecant and you don't have a sine without an angle. It is impossible to have an opposite over hypotenuse unless you identify whichever angle you're working with. So when you see me write all of these things, and I'm going to be this specific, see how I have sine of theta is equal to 1 over cosecant of theta? Don't get lazy and don't skip putting theta there. Theta matters. The angle matters. It has to be the same angle. Otherwise, it is incorrect. If you're working any of the problems that I'm about to show you later on, if you do not put the angle, you will not receive full credit. That's a simple request. The angle can be theta, it can be x, it can be a b, an a, depending on how we set up the problem. But don't get lazy. Don't just write tangent of theta. Don't just write sine, put sine of theta divided by cosine of theta. If I ask you. So that brings us to some of these jokes, if you will, that you can now understand now that you have taken trig. For example, if you were wondering what this is, because on your notes you're like, what the heck is that? You should now understand my first joke for you. The sine of an angle called gerene divided by the cosine of an angle called gerene. You all know what the answer is now, I hope, using a quotient identity. It's equal to, say the answer out loud. Oh, isn't that wonderful? It's great. You are now smart enough to understand this first picture joke. And what you used is something called a quotient identity. You would not know what that means if you have a black and white printed copy. Maybe you do. I don't know. It might look like a tomato. I don't know. But now that you see it, now you get it. Some of you, I might be too young for this. But Netflix, some of you have actually seen this episode. It's a sitcom, as a matter of fact. Seen this sitcom? There is a sitcom that was around when I was in college, back in the early 2000s, late 90s. They're called, what is this called? See if you know. Seinfeld. Good. That's a sitcom. I believe you can see it on Netflix now if you want to see a show about nothing. That's the name. That's what the whole funny thing is about. There's a comedian, and him and his friends get into predicaments about nothing. Sine of an angle is equal to the opposite over hypotenuse. Seinfeld. And if you ever saw the show, you would know that it says Seinfeld right there. You're all probably too young for knowing who this person is. So this is the sine of angle B divided by the tangent of angle B. And if you're wondering how the problems are going to look at this. Sine of B. Tangent of B can also be written as, let's switch it to its quotient identity. How about, isn't that the same thing as sine of B over cosine of B? Is that the same thing as tangent of B? And so, instead of dividing by tan, we're dividing by sine of B over cosine of B. You should already know how to handle division by a fraction. Isn't that the same thing as multiplying by the reciprocal? What is the sine of B divided by sine of B? How many times does that go in? So this simplifies to what? Or his name is Bill Cos B. Cosine of B, cos B, same thing. That's where that joke comes from. You are now seeing how this chapter works. This chapter is the end of Unit 9 is all about taking things that you know, reciprocal identities, and taking them from what they are, using some of the identities to simplify. You could think of them as puzzles. Puzzles that will simplify, and in my opinion, it's very satisfying to make. Oh, it's Cosby. It's Seinfeld. Oh, it's Tangerine. So satisfying. The first way we're dealing with problems are with these types of identities. Reciprocal and quotient identities. The other types of problems that you're going to deal with, we'll deal with Pythagorean identities. There are three. The first one is sine squared of theta plus cosine squared of theta is equal to 1. If you can't read that in your notes, write it down. The second one is tangent squared of theta plus 1 is equal to secant squared of theta. The third one is 1 plus cotangent squared of theta is equal to cosecant squared of theta. You will need to know all three. I would recommend memorizing all three, but if you have short amount of open brain space, at least memorize the first one. I will show you a way to go from the first one to the second and to the third in just a little bit. These three identities will not be used in the way that I am showing you here. I will never ask you sine squared of theta plus cosine squared of theta is equal to 1. You will never see something just like that by itself. They are not used that way. They are used to go from three, not from three terms. They are used to go from, let me close that down a little bit. They are used to go from two terms down into one term. So even though this thing has three things there, I'm going to use it to go from these two terms down into one term and make it smaller, essentially. So anyways, primarily, we're going to go from two terms down to one. Sometimes you might go from one into two, but not very often. Okay? So here we go. Here's how it is used. This is what I want you to know from this section. 1 minus cosine squared of theta is equal to sine squared of theta. Write that down. 1 minus cosine squared of x. Ooh, I'm sorry. It says x. The angle is x, not theta, Mr. Paramo. Sine squared of x. Much better. Now the angles match. How did I know that this is the same thing as that? Well, it's real simple. I'm using the first identity. The first identity, if I take that first identity and I subtract cosine squared of whatever this is, and I do that to the other side, then what happens is that cosine squared, take away cosine squared, would just cancel. And you have 1 minus cosine squared. And what is that equal to? It's equal to sine squared. What I'm doing is I'm taking that first identity and I'm manipulating it by subtracting something to the other side so that I know what these two pieces are the same thing as. 1 minus cosine squared of the angle is equal to the sine squared of that angle. In the same way, you should be able to figure out, well, what's secant squared of the angle minus tangent squared of the angle? You should be able to do that. You should be able to figure out what the cotangent squared of theta minus the cosecant squared of theta is equal to. As a matter of fact, let me give you some time. North person, I want you to try to figure out what this answer is. No, actually, you both are going to figure out this one and that one. And the north person, you're in charge of saying, I got this for this one, and I think it's this because. South person, you're going to explain the bottom one. I got this because, and you're going to explain it to your partner. Let me give you about 2 minutes. Feel free to discuss it with your partner. Go.
I got one.
Yeah, I got one. When Gavin gets back. Show of hands, please. How many of you got 1 for the second one and -1 for the third one? Raise your hand. Awesome. That's at least 75% of the class. So, for the people who did not get it, let's look. If you subtract tangent squared and subtract tangent squared, it's equal to a +1 for this one. Now, cotangent squared is positive, and you're subtracting cosecant squared over here. You want to move the 1 to the other side of the equal sign so that it's by itself. You have to subtract the 1 over there. That's what it's equal to, a -1. Sometimes it's 1, sometimes it's -1, sometimes it's sine squared. But you're taking it from 2 terms down into 1 term. I'm hoping that makes sense. Any questions? Then, the last thing I want to cover today, this is how it's used. Most important thing, how do we use it? We have to know how to manipulate them. We have to know what they are to be able to manipulate them a little bit, to go from 2 terms down to 1 term. Where does it come from? That's the last thing I want to answer today. Where does it come from? It comes from this. A triangle inside a circle. Very similar to what I showed you for the unit circle, right? Same thing, same exact picture. And I bet you guys know the Pythagorean Theorem. You've used that before, right? What is the Pythagorean Theorem? Good. But that's an A, a B, and a C. And this is an X because it represents going in the X direction. We don't know how many units. This is for any horizontal distance, X. This is for any vertical distance, Y. It could be positive, it could be negative. It could be in the other quadrant. We don't know. And then there'll be a radius and then some unknown angle. So what we need to do is we need to use the Pythagorean Theorem on these 3 variables. How about x squared plus y squared is equal to r squared? Isn't that how those 3 are related to each other? That's the first thing I need. I'm going to circle it. I'm going to come back to that later. The second thing I need is the sine of this angle, theta. You cannot have an opposite over hypotenuse unless you have an angle. That is why I mark people wrong when they forget angles. Because you can't have an opposite over hypotenuse without the angle. Now that I said angle theta, you should know that I'm talking about the opposite over hypotenuse of that triangle. How about y over r? We abbreviated that to sire in the last unit. You remember? In unit 8? Now what if we were to solve this for r, solve this for y? We would times by r and times by r. We're going to come back to this in a second. Y is equal to r sine theta. The r hasn't gone away. It's still part of this problem. Cosine of theta, same thing. The adjacent over hypotenuse. Times by r, times by r. X is the same thing as r cosine theta. I'm going to use that. I have 3 things. I have x equals x squared plus y squared equals r squared, and then I have what y is, and I have what x is. Let's substitute in, instead of y in this problem, let's put that in. Instead of x in that problem, let's put that in. Here you go. X squared plus y squared equals r squared. I'm going to simplify that. r cosine theta times r cosine theta is r squared cosine squared of theta. I'm going to simplify that. R squared sine squared theta equals r squared. And then I'm going to divide everything, the left side by r squared and the right side by r squared. R squared goes into r squared goes into r squared once, and r squared goes into r squared one time. And look what you get. This is Pythagorean identity number 1. Also known as sine squared of any angle plus the cosine squared of any angle will always equal 1. And we can also take that first Pythagorean identity and we can divide everything by cosine squared of theta. When you divide by cosine squared, the reciprocal identities, make sure I say this, the reciprocal identities and the quotient identities work for squared terms as well. Meaning, sine squared of theta divided by cosine squared of theta, just because we wrote down sine of theta over cosine of theta, that still simplifies. It's just a squared. How about tangent squared of theta? That's 1. 1 divided by cosine of theta is actually secant, but it's squared, so secant squared of theta. And guess what this is? This is your second Pythagorean identity. We'll end right there.